Hello and good afternoon to all. Whoever will be watching this video, I think their mains exam has been conducted and they have cleared the mains exam. So, congratulations to all of you for clearing one of the most coveted exams in our country. I hope in a similar fashion, through the help of our videos, you clear advance as well and get into good colleges. So, my name is Prabhat and today I am going to conduct a JEE advanced session on matrices and determinants. So before beginning, let me share my screen and then we will be ready to go. Okay guys, so today we will be discussing about matrices and determinants and the questions that have been inculcated in this PPT is mostly like 99% of the questions are from previous year JEE advance. So first of all, before beginning the session, I would like to tell you that JEE Advance is a difficult exam, but sometimes some questions are very easy. But since there is a pressure of the difficulty being there in the exam, we somehow forget our basic concepts. So before beginning the session, let me remind you all that this is nothing new. The concepts that we will use is exactly the same concepts that you might have studied for JEE mains, and we'll apply the same concepts and we'll get to our answers. Okay. So let's move ahead. So the agenda of our today's session is to discuss previous year questions of JEE Advance. So let us begin our session with this first question. So here, let us first try to understand the question and then we will try to get to the answer. In the first question, what the question says to us is, if A is a 3 into 3 non-singular non-singular matrix such that AA transpose is equal to A transpose A. Okay. So this this property, this is not a property, but this is specifically given that A is such a matrix that this condition follows. And B in terms of A can be written like this. So they are asking what is the value of B transpose. Okay. So take some time to understand the question and then we will follow for the answer. So let me read it once again. If A is a 3 into 3 non-singular matrix such that AA transpose is A transpose A and B is equals to A inverse of A transpose, then what is the value of B transpose from the following options? So this is our question. Okay. Now let's try to solve the question. So first of all, what has been given to us? The given thing is that A transpose is equals to A transpose A. Okay. So to solve this question, like there is one property that we have studied during our preparation. Okay. And that property looks like this, that transpose of a transpose gives us the same matrix. Do you guys understand this property? Do you guys remember this property? If not, then please remember this property. This will help us solve this question. Okay. So what has been asked from us is the value of BB transpose in terms of the given options. Okay. So BB transpose, let us just write B transpose. Okay. So the value of B is given to us. The value of B is given to us, right? So I'll just simply write the value of B, which is A inverse of A transpose. This is B. And what is the value of B transpose? We will simply apply transpose to the value of B. Correct? Now, this A inverse A transpose, I am going to keep it as it is. Okay. And then you know that A transpose is what? Is equals to A. So I will write down A and then A inverse transpose. Okay. So now I am taking this A with A inverse. I am taking this A with A inverse. So what I will get here is A inverse A and A transpose into A inverse transpose. Or I can also write this. See, I can write this as something else. I can write this as A transpose inverse as well. Okay. So here these terms will again be rearranged to A inverse A transpose and A inverse transpose. Right? I hope you guys understand this. We are simply applying very basic properties of matrices. Okay. So we know that A inverse A is I. And then again this A transpose into A inverse will be I. So this will result out to be I into I. And we know that multiplication of i's is I in matrix. है ना? What is I? You guys know I, right? I is an identity matrix. So we got the value as I, and you can see there is an option also. Option B. Option B is the correct answer. So the answer to this question is option B, which is given as I. Okay. So you can see, right, that this was a very easy question, but this was also asked in JEE Advanced. So the beauty of matrices is that sometimes the questions might seem or look like they are difficult, but if you try to solve them, they will become very easy to you. Okay. So moving ahead, let us try to solve the next question for our session. So I have also attached answers in the PPT. So you can, whenever you see, this is the answer. If you want to take the screenshot, you can take the screenshot as well. Okay. Now here. So guys, in this question, you can see that a matrix A has been given. A is given. Okay. I'm changing my ink. This yellow color would look beautiful. A is given to us, and we are supposed to find something for something, or maybe I can say adjacent for the matrix 3A square plus 12 times of A. Okay. So now what we can do here is, first we will try to find out A square matrix, and then we will find this complete 3A square plus 12A. And then what we will do, then we will add them and try to find out the adjacent. So in this question, to find out the of adjacent of 2 into 2 matrix. See, since the given matrix is 2 into 2, we already know that A square will be 2 into 2 matrix. A will be 2 into 2 matrix. So 3A square plus 12A will be 2 into 2 matrix. So to find the adjacent of 2 into 2 matrix, you can remember the trick that adjacent of A, B, C, D matrix is simply exchange A and D, exchange A and D, you write D here, you write A here, and keep BC same but with a negative sign. So this generally gives us the adjoint of 2 into 2 matrix. So this is the trick that you can apply to get to the answer. But before getting the answer, we will have to find out the values. So to find A square, I am writing A into A, which is 2 into 2 minus 2 minus 3 minus 4 and 1. And again 2 minus 3 minus 4 and 1. Okay. So we all know how to find A into A. I'll do first row into first column, which will be 2 into 2, then plus minus 3 into minus 4. Okay, so this part is our trick. This here I'll be solving. Then first row into second column, which is 2 into minus 3 plus minus 3 into 1. Now second row into first column, minus 4 into 2 plus 1 into minus 4. Then second row into second column, minus 4 into minus 3 plus 1 into 1. So our A square matrix will become what? 2 plus 2, 4, 4 plus 12, 16, 16, 2 minus 6, minus 3, minus 9. Here minus 8, minus 4, minus 12. Here you will get 12 plus 1, 13. So 16 minus 9 minus 12, 13. This is what? This is our A square matrix. Okay. So to get 3A square, what do we do is we multiply this 3 to all the elements of the matrix. Okay. So let us try to find out 3A square in the next step. So 3A square will be, we already know that 3 into 16, 3 into minus 9, 3 into minus 12, and 3 into 13. So you will get the 3A square matrix as 48 minus 27 minus 36 and 39. Now we found out 3A square. Now we will find out 12A. 12A means we multiply 12 to all the elements of matrix A. So 2 minus 3 minus 4 and 1 is are our elements of the matrix. So 12 into 2, 12 into minus 3, 12 into minus 4 and 12 into 1. So this will come out to be 24 minus 36 minus 48 and 12. Now we are supposed to add this 3a square plus 12a. So what we will do here is we will add these two matrix. These two matrix we will do the addition and we will get the answer that we will get here. 3a square plus 12a will be 48 first element with first element. 48 plus 24 is 72. 27 plus 36 is 63. 36 plus 48 is 84. And 39 plus 12 is 51. So we got the value of 3a square plus 12a. Okay. So after getting the value of 3a square plus 12a, what are we supposed to do? We are supposed to find the adjoint of this matrix. Na? So what I'll do here, I told you a trick, right? So you can directly apply the trick to get the adjoint of 3a square plus 12a. So in adjoint, what did we do? We interchange these two terms. So here 51 will come and here 72 will come, and the rest two terms we keep as it is but with a minus sign. So you will get here 63, here you will get as 84. So this is the answer to our question that was asked. I hope this question is clear to you all. So compared to the previous question, this was easier, but here only calculation was required and you had to find out the matrix 3a square plus 12a by putting some arithmetical effort. Now, so this question is done. Let us move forward with the another question. So you can see here, they have like applied they have directly written 3a square 12a. Na? But in exam, there is no method, like we'll have to solve it manually like how I did. So 3a square and 12a, like you cannot achieve it like this in simply very short method. So that is why you have to solve each and every step and get to the answer. The only trick that was there is this adjoint. And to find the adjoint of 2 into 2 matrix, you can use that trick rather than going through the harsh process of solving. Now the first impression of this question, is that, oh my God, complex number as well as matrix and something has been included in this thing. How will we solve it? So let's not worry whatever is written in the question. First of all, let us try to understand what the question is trying to tell us and what is the purpose of the question and what it has asked from us. Okay. So first of all, so the given omega in this question is a complex cube root of unity with omega not equal to 1. Okay. So what does this mean? This part of the question is, so in complex cube root of unity, you remember, right? 1 omega and omega square. You used to get these two values, correct? You used to get these three values, sorry. So what it is saying is, apart from this one, omega can take these two values. Okay, so these two values are possible for omega, but not 1. And P is such a matrix. P is a matrix, right? This is a denotion of matrix, this square brackets. So P is such a matrix where small p ij, okay, like each element of P matrix can be represented by small p ij. Now, what does this small p ij means? The meaning of small p ij is given in the next part. It is saying that P is an n into n matrix. Okay. So it can be 2 into 2, it can be 3 into 3, it can be 4 into 4, like this. Okay. N into N matrix with Pij. So the definition of Pij, that means every element has been defined in this fashion, where Pij is said to be omega power I plus j. Okay. So consider like first element P11. P11 will be omega power 1 plus 1, which is omega square. P12 will be omega power 1 plus 2, which is omega cube. P13 will be omega power 1 plus 3, which is omega power 4. Similarly, P32 will be omega power 3 plus 2, which is omega power 5. So in this fashion, we have to input all the elements of the matrix. So this was the part where we understand the question. After this information, they are saying that P square should not be equal to 0. P square should not be equal to 0. Then what is the value of n? So they are saying then P square is not equal to 0 when n is equals to what? Okay. So this is a more than one answer type. Okay. In advance, you will get questions in which there will be multiple options which are correct, and you have to mark all the options to get full answer or to get full marks. Okay. So to solve this question, let us, like I am saying, for n equals to 3. Okay. Why I am using n equals to 3 is that this is like my basic instinct, which is saying that you can get information out of n equals to 3, and this instinct comes through a little bit of practice. So for n equals to 3, we can check what will be the P matrix, right? When n is equals to 3, then P is a 3 into 3 matrix, correct? So the P matrix will look like Pij, that is P11, right? Here it will be P11, here it will be P12, here it will be P13, here it will be P21, here it will be P22, P23, then P31, P32, P33. And we already know what are the values of P11, P12, because here they have defined. Here they have defined the values of P11, P22, P23 and all this. So here you will get P11 means omega square. The sum of ij is 2. P12 is omega cube. P13 is omega power 4. P21 is omega cube. P23 is omega 4. P223 is omega power 5. Here omega power 4, omega power 5, omega power 6. So we got our P matrix. So finding P matrix was not at all difficult. Now what we have to do is, let us find P square. Okay. Let us try to find P square matrix. So P square will be the multiplication of omega 5, omega 6 in the similar fashion. Omega square, omega cube, omega 5, omega cube, omega 4, omega 5, omega 4, omega 5, omega 6. Okay. So to find the P square matrix, we are trying to solve this multiplication. And to solve this multiplication, what I'll do is first row into first column. So I'll get omega square will be omega power 4. This will be omega power plus omega power 6. plus omega power 8. Now this will become what? First row into second column. This will become omega power 5 plus omega power 7 plus omega power 9. First row into third column. This will become omega power 6 plus omega power 8 plus omega power 10. Similarly, here it will become second row into first column. Second row into first column. This will become omega power 5 plus omega power 7 plus omega power 9. This will become second row into second column, omega power 6 plus omega power 8 plus omega power 10. So you can see the pattern repeating, right? So here it will become third row into second row into third column, omega power 7 plus omega power 9 plus omega power 11. Okay. Now the third row of this matrix will become omega power 6 plus omega power 8 plus omega power 10, omega power 7 plus omega power 9 plus omega power 11. So this, we have got this matrix. Okay. Now what I am doing here is I am taking, see, the least value is omega power 4, right? Omega power 4 is the least in all these terms. So I can take omega power 4 outside from all the elements. So what will remain here is 1 plus omega square plus omega power 4. Okay. Now after this will become omega plus omega cube plus omega power 5. This will become omega power omega square plus omega 4 plus omega power 6. This will become 1 omega plus omega cube plus omega power 5. This will become omega square plus omega 4 plus 7. So this pattern is repeating. So we can tell, see, if you take out omega common from this, like I am going to tell about every element. Now you can understand that every element in this matrix is going to become 0. Like, but how? But how, that remains our mystery and question. How every element is going to become 0, sir? Omega power 8. Okay. So now if I tell that, if you know that 1 plus omega square plus omega power 4 is equals to 0, then you can definitely tell that each element in this will become 0. How? So what we are going to do here is, first of all, we'll try to find out if 1 plus omega square plus omega power 4 is 0 or not. Okay. So what will this become? See, we know that to find x cube minus 1 equals to 0, to find while finding the cube root of unity, this can be broken down as x minus 1 into x square plus x plus 1 equals to 0. So we get x equals to 1 from this part, and we get omega plus omega square from this part, right? So x square plus x plus 1 equals to 0 has two roots. One is omega and another root is omega square. So when you put omega, you get omega square plus omega plus 1 equals to 0. There is one relation that we already know, we studied in complex number. And the other relation is, after you put the value omega square, you get omega power 4 plus omega square plus 1 equals to 0. So from this we can conclude that this value is 0. Now if you take omega common out of this term, you will get again 1 plus omega power 4. 1 plus omega square plus omega power 4. This will become 0. If you take omega square common here in this term, omega square, then this will become 0. If you take omega common here, this will become 0. This will become 0. Similarly, every term will become 0. So therefore, we can say that our P square matrix was 0, 0, 0, 0, 0, 0, 0, 0, 0. We got our P square matrix 0, but what was the condition that we first used to get this P square is 0? We got this value when n was equal to 3. When n was equal to 3. So for all multiples of n, for all multiples of n or n equals to 3, P square will come out to be 0. Therefore, P square for P square not equal to 0, n should not be a multiple of 3. And if n is a multiple of 3, then we are getting P square value as 0. So if n is not a multiple of 3, we will get our P square value other than 0. So therefore, our answer in this question, if you go to the question, only C option is a multiple of 3 and A, B, D. All these three options are our answer because they are not a multiple of 3. So the answer to this question, kids, is A, option B, and option D. All these three are answer to this question. So this was an interesting question, but it was very easy. Why I am saying this question is easy is because just normal multiplication of matrix is required. And then if you have studied well for mains, you already know that 1 plus omega square plus omega power 4 will give us 0 value. So therefore you can conclude all the elements of this P square matrix will be 0. So in this fashion, we can tell that P square is a null matrix very easily. So this was a lengthy question, but an easy question. This required rough work, but this was a very easy question and very scoring one. And this is asked in multiple, more than one answer type. So more than one answer type question is actually a scare question for students. Generally, they fear that a lot because there is a chance to miss at least one option or two options. Sometimes all the four options are correct. So you have to mark all the four options. So in this manner, this type of question is treated as a difficult question in terms of answering them. But getting to the solution of this question might be or might not be like compared to the mains level, it will be on the mains level itself. Sometimes this question is of mains level but has been asked in advance because there is only one trick and you have to mark multiple answers. Now in this question, you guys can see what is the question asked, right? The question is, if A is given and I is given, then you have to find out 10 times of A inverse in terms of A and I. 10 times of A inverse in terms of A and I. So tell me one thing, will we will we will we see this question and try to find out A inverse first, and then we will try to find out 10A inverse and then compare to all these four options given to us? Is this the method? No, right? There must be something else and easier way to approach this question. So the easier way to approach this question is to remember one thing, that is characteristic equation of matrix. Characteristic equation of 2 into 2 matrix. Here in this case it is 2 into 2 matrix. Characteristic equation of the matrix is given by mod determinant of A minus lambda I is equals to 0. A minus lambda I is equals to 0. So following this, I will write as determinant of A minus lambda I. So A minus lambda I will be A is first element is 2. First element of I is 1. So lambda I will become lambda. So this will become 2 minus lambda. The second will stay as it is. It will become 2. The third will be remaining 0 because the third will be remaining as it is because here I has 0. And the fourth will become 4 minus lambda. And this is equals to 0. Okay. So to find the determinant of this matrix, 2 minus lambda into 4 minus lambda plus 18 is equals to 0. So this becomes 8 minus 6 lambda plus lambda square plus 18. Sorry, this here it will be minus, not plus. And minus, this is equals to 0. So what we get is lambda square minus 6 lambda plus 10 equals to 0, right? So you got lambda square minus 6 lambda plus 10 equals to 0. Okay. So here you can note that A is lambda I. You can put, so you can also put lambda. So this question, so we know the relation between A and lambda. So what we can do here is this equation can be written as A square minus 6A plus this is minus 18. So here it will be minus 10. Here it will be minus 10I equals to 0. Now what I'll do is multiply by A inverse to this equation. So what this will become A inverse into A square minus 6 times A inverse minus 10 times I A inverse equals to 0. So A inverse A square will become A inverse A minus 6I minus 10 times I into A inverse is A inverse itself. So you will get 10 times A inverse will be equals to, here it will become, see, we all know that I identity matrix into the matrix is the matrix. Sorry, yeah. So I times A inverse is I and IA is equals to A. So A minus 6I. So 10 times A inverse can be written as A minus 6I. So the answer to this question is A minus 6I. So this was not very difficult. You should remember the characteristic equation of the matrix and then it becomes very easy to solve, right? So all these questions that we have done till now, if you might note it down that these questions have been asked in IIT JEE Advanced. All these questions are from advanced paper. So you can see that these questions are not very difficult. So matrices and determinants, guys, is a very scoring topic. it is a little bit of boring, but it is also very scoring. So we should always study matrices and determinants so that we fetch all the marks in this topic. Let's move ahead. Now, now in this question, first of all, let us try to understand what the question is trying to tell us. Let P be a matrix, P is given, and I be the identity matrix of order 3. If Q if Q is a matrix, here you can see Q is given as a matrix of elements Qij is a matrix such that P power 50 minus Q is equals to identity matrix. So this relation is a little bit of importance to us. So what is the value of Q31 plus Q31 plus Q32 upon Q21? Okay. So we have to find out this value by the help of this particular identity which is given to us and the matrix. Okay. So to solve this, first of all, let us see that P square, what is the value of P square? Sorry. So see, can I write P? P is given to us as 1, 0, 0, 4, 1, 0, 16, 4, 1. So can this be written as 1, 0, 0, 0, 1, 0, 0, 0, 1. So I am writing this plus 0, 0, 0, 4, 16, 0, 4, 0, 0. So what I have done is I have just rearranged the elements of P such that it comes out to be an identity matrix plus some matrix which I am calling as, let me call it as A. Okay. So this matrix I am calling it as A. All right. So now we all know that A is known. So let us try to find out A square. Okay. Let us try to find out A square. So if you try to find out A square, you will see that. So I'm just writing down 400, 1640 into 000, 400, 1640. So if you try to solve this, you will get first row into first element. So 0044. First row into first column. So 0 into 0, 0 into 4, 0 into 16. You will get here 0. Then first row into second column 0, 0, 0 again. Since first row has all the elements of 0, so we'll get first row into third column is also 0. Now, second row into first column, you will get 0, 0. Second row into first column, you will get 0. Second row into second column, you will again get 0. Second row into third column, all the elements in third column are 0. Now, third row into first column, you will get 16 into 0 plus 4 into 4, 16 and 0 into 16. So 16 will remain. Third row into second column will result 0. Third row into third column will result 0. So you can see that few more elements after you did A square, after you found out A square, few more elements of the A square became 0. Now from this, if you try to find out A cube, if you find out A cube, Okay, from this, now we have gotten a square, right? If you try to find out a cube will be a square into a, which is 0, 0, 0, 0, 0, 0, 16, 0, 0, and a matrix was 0, 0, 0, 4, 0, 0, 16, 4, 0. So after you solve this, you will get first element as 0, second is 0, third is 0, 0, 0, 0, 0, 0, 0. So a cube comes out to be 0, right? Like null matrix. A cube comes out to be a null matrix. So from this, you can conclude that a power n is always 0 if n is greater than or equal to 3. है ना? Can we conclude this? Can you guys understand how this happened? So a power n will be 0 if n is greater than or equal to 3. Now p power 50, we all know that we made the element of p as I plus a, है ना? तो p power 50 will be equal to I plus a power 50. So now here, since these are two elements, I am applying binomial theorem. I'll get 15c 0 I power 50 plus 50c 1 I power 49 and a plus 50c 2 I power 48 into a square, right? After this, all the term will have a cube or greater values, right? So we already found out that a cube is 0. So we will neglect this thing. And a cube is a null matrix. So what are we left with? We are left with 50c 0 is 1. I power 50 is I. 50c 1 is 50. I power 49 is I, and I into a is again a, plus 50c 2. 50c 2 is how much? 50c 2 is 25 into 49, and I power 48 is I and a square. I into a square will be again a square, right? So we have gotten as p power 50. The value of p power 50 is I plus this thing, right? So let us go back to the question and see what was given. P power 50 is I plus q. Yeah? So this element of this equation is equivalent to q, right? And every element, like every, so this is equivalent to q. So I'll write it in the next part. This will become q is 50 times a plus 25 into 49 times a square. So we already know a is given to us as a, what we wrote down for a was 0, 0, and here it was 16, 4, 0 plus 25 into 49 a square. A square was how much? 0, 0, 0, 0, 0, 0, 16, 0, 0, right? So this was our value of q. Okay, just give me a second, guys. There is some technical issue. So now we know that the elements of Q were written as Qij. So we have to find out what we are supposed to find out Q31 plus Q32 upon Q21. So Q31 plus Q32 plus sorry upon Q21. So what is Q31? 31 is this element, right? So Q31 will be Q31 will be 50 into 16 plus 25 into 49 into 16. So Q31 will be coming from here one part and one part from here. Okay. Q32 will be 50 into 4 plus 0. Okay. So this will conclude for Q32. This will come for Q32. Okay. And Q21 value will be 50 into 4 plus 0. So what do we get? Our answer will be 50 into 16 plus 50 into 49 into 8. This is Q31. And I have just shifted 2 and made that as 8 plus 50 into 4 upon 50 into 4. Okay. So this will become, first of all, I'll divide it with this. So this will become 50 gets cancelled. 16 will go with 4 plus 50 into 4, 50 into 2 here. So we'll get 98 plus 1. So answer is 103. So the answer to our question is 103. Okay, guys. I hope you understood this question. Let us try to solve another question. Okay. Now this question, in this question, you can see, even though this is an advanced level question, the information that has been asked to us is not very difficult and you can solve it very easily if you know few important properties. So the properties that we will require to solve this question, the properties that we require to solve these questions are determinant of A transpose is equals to determinant of A. And the other property is A transpose inverse is equals to A inverse transpose. Okay, guys. So we know that A inverse is equals to adjoint of A upon determinant of A, right? A transpose inverse will become, what will be the value of A transpose inverse? It will be, A transpose inverse will be adjoint of A transpose upon determinant of A transpose. है ना? So instead of writing determinant of A transpose completely, I will write determinant of A transpose. So this is also equivalent to adjoint of A transpose upon determinant of A, right? Since determinant of A transpose is equals to determinant of A, so I can write this equation like this. Now adjoint of A transpose, adjoint of A transpose can be written as determinant of A into A inverse transpose. Because A transpose inverse, by using this property, I can write A transpose inverse as this thing. Correct? Okay. So I'll get the value of adjoint of A transpose as determinant of A into A inverse transpose. Right? So now from this thing, can I write this as determinant of A into, I can write A inverse as adjoint of A upon determinant of A transpose, right? So this thing can again be written as determinant of determinant of A transpose is equal to determinant of A itself. So I am writing it as determinant of A upon determinant of A into adjoint A whole transpose. Correct? So you get as adjoint of A transpose is equals to adjoint of A transpose is equals to adjoint of A whole transpose. So from this you can conclude that adjoint of A transpose minus adjoint of A whole transpose will come out to be 0. And therefore this answer will be null matrix. Yeah. So the answer to this question is null matrix. So the only two properties that we used and manipulated our equation is by using these two properties, right? So remember, these two properties are also very important. These two properties help in solving a lot of question based on determinant and adjoint. And this relation is also important. So these three relations were super helpful to solve this question. Okay. Let us try to solve another question. Okay. Now this question you have been given as the value of A is given 0, -1, 1, 0. So in this question, you have to manually check all the options. You have to manually check all the options. So here, if you try to find out A square, let us try to find out A square. A square will be 0, -1, 1, 0 into 0, -1, 1, 0. This will come out to be, A square will come out to be -1, 0, 0, -1. Okay. So first row into first column, first row into second column, second row into first column, second row into second column. This is minus I, right? Identity matrix is 1, 0, 0, 1. This is -1, 0, 0, -1. So this is minus times of identity matrix. So the value of A square you got as I. Now A cube will be equals to 0, 1, -1, 0. And A power 4 if you try to solve this, you will get as 1001. So this is I. So if you check, so then which one of the following statements is not correct? So for first option, a square plus I, a square is minus I plus I is equals to a into a square, which is minus I. So you get 0 equals to a into minus 2I. So this is not true, right? This is not true. This cannot happen because A is a matrix which is known to us and I is a in identity matrix. So that is why this is not true. Hence option A is our correct answer, because they have asked us which of the following options is not correct. So first option itself is not correct. And let me tell you that this was a single correct answer type of question. So that is why as soon as you check option A and you get the answer that A is the correct answer to this following question asked, then you need not check all these conditions. Don't waste your time by checking all these three conditions, okay? Because this was asked in single answer correct type. So in this manner also we can predict that B, C, D will not be an answer, and hence not, let's not waste our time checking these questions. Some students, what they do is they check this also because of the fear that they might have gotten it wrong in the first step. So don't fear if your steps are correct, okay? Don't waste time. Time is of essence. Let us move on to the next question. So this question was pretty easy, right, guys? Before moving on to the next question, yeah, I hope you are finding this question easy. And all the out of all the previous questions that we did, I only one question was very difficult, and not also difficult in the sense of very tricky or the question was like out of the box. Nothing was out of the box. It was difficult. I'll also just go through that question since it has already been more than an hour. Let us just see this question. I'm talking about this question. So this question was a little bit trickier, but not that trickier to to scare us. We have cleared mains. So after clearing mains, you guys should know that you are not supposed to be scared. Mains is a very difficult exam and you have passed that difficulty. So advance will also be a similar exam to you guys. Okay, so only one question was a little bit trickier and lengthy. Otherwise, all the questions that we have done till now is very, very easy. Very, very easy. So, guys, the point being that you are not supposed to get scared from the questions of advance. Advance is also easy if you know how to apply whatever you are learning. So if you are able to apply whatever you have learned till now, then you will find the exam to be very, very easier. Okay, so moving on to the next question. What the question is saying is let M be a 2 into 2 symmetric matrix with integer entries. Then M is invertible if. Okay, so what is a symmetric matrix? Aij is equals to Aji. Now all the elements follow this rule, then the matrix is symmetric matrix. So we all know that. After that, they are saying M is a 2 into 2 matrix wherein all the entries are integral. Then M is invertible if. So there is condition given to us. So we have to find out which of these following is true and which of the following might be correct for the given question. So what I'm telling you guys is that this question is more than one correct answer type. Okay, more than one correct answer. Now see the question and try to figure out whenever you get to hear the word invertible. A matrix is invertible. A matrix is invertible. A matrix is invertible. So whenever you hear this, the first basic instinct that you should get is that for an invertible matrix, the determinant cannot be equal to 0. The determinant of an invertible matrix is never 0. So what is this, guys? This is a property. This is a property of invertible matrix. So I cannot go through the proof here, but I am telling you that this is one property which you might have studied during the preparation. So please remember that this is an important point whenever invertible matrix comes into picture. So we can also say that since the determinant is not 0, we can say that the matrix should be non-singular. The matrix should be non-singular. So let us say that M is a matrix and let us name the element as A, B, C, D. So we can tell that determinant of M is AD minus BC, which should not be equal to 0 since M is an invertible matrix. And since it is a non-singular matrix, then the matrix will look like something like this. The matrix will look like A, B, B, D. Okay. So here this question, in this question, the M becomes, since M is a non-singular matrix, M becomes A, B, B, and I am just replacing this with C. So this condition applied to the same matrix will become AD minus, sorry, AC minus B square should not be equals to 0. That means what, guys? AC should not be equal to B square. So M is a diagonal matrix with non-zero entries in the main diagonal. Okay. M is M is a diagonal matrix. M is a diagonal matrix with non-zero entries in the main diagonal. Correct? The first column of matrix M is the transpose of the second row M. The second row of M is the transpose of the first column of M. So we cannot tell these two things. The product of entries in the main diagonal of M is not the square of an integer. So this is the main diagonal, and the product of these entries in main diagonal should not be equal to B square. And B is an integer because the question told us that all the entries in this matrix are integer. So we already know that AC is not equal to B square, and hence option D is also correct. So our answer is option C and option D. Okay, guys. Let us move on to the next question. let us move on to the next question and try to solve the question. So the next question is telling us that how many 3 into 3 matrices M with entries from 0, 1, 2. So the set of entries that the matrices M can have is only 0, 1 or 2. Okay, so the set of entries that the matrices can have is only 0, 1 or 2. So tell me, the question that is asked is how many matrices are there for which the sum of the diagonal entries of M transpose M will be equal to 5. M transpose M will be equal to 5. So let us call M as, let us say that M is a matrix. M is a matrix. Let us assume A1, A2, A3, A4, A5, A6, A7, A8, A9. So M transpose into M will be written as A1, A2, A3. You know what transpose is, right? Changing rows into columns or vice versa. A1, A2, A3. This becomes A4, A5, A6, A7, A8, A9. And A I will write as it is. So, what are we supposed to look for? Are we supposed to find the whole M transpose M matrix, or will the only the diagonal entries of M transpose M matrix will suffice to solve this question? So, only the diagonal entries of M transpose M is more than enough to solve this question. So, what will be the diagonal? So, diagonal diagonal entry, the for the first element, diagonal entry will be a1 square plus a4 square plus a7 square. Then the second will be a2 square plus a5 square plus a8 square. The third diagonal element will be a3 square plus a6 square plus a9 square. So it is saying that sum of all these diagonal entry is equals to 5. So in how many ways can we do that? So there can be like, I'll take you to the next slide. So we already know our diagonal entry. Okay, so I am saying that I know my diagonal entries. Okay, so what is my diagonal entry? My diagonal entry is where a1 square, the sum of my diagonal entry is where a1 square plus a4 square plus a7 square plus the second diagonal entry would have been a2 square plus a3 a5 square plus a8 square. The third diagonal entry will be a3 square plus a6 square plus a9 square, and this is supposed to come out to be 5. So let us go to the question. How many entries from 0, 1 and 2? So we also know what these values like A1, A2, A3, A4, A5, A6 and A7, A8, A9. So all these AIs can be taken only from the set of values 0, 1 and 2. So there can be two cases I am saying when this is possible. When it is possible, in the first case, there are 9 AIs, right? So there are 9 AIs. So 5 can be done from C. We can add, and all these AIs have been squared. So this is AI. So the AI square will be, the entries for AI square will be 0, 1 or 4, right? So when you select value of AI to be 0, it will give AI square 0. If you select value of AI to be 1, it will give AI as 1, AI square as 1. If you select 2, it will give AI square as 4. So this is possible when 5 of the AI is equal to 1 and 4 of the AI is equals to 0. So then we can get 5 times 1 plus 4, right? So this can be done. This can be done as, this can be done in how many ways? So there are 9 AIs. Okay. So you have to select 0 for 4. Okay. So you have to choose which 4. Okay. So this can be done in 94 ways, right? If you choose any 4 to be 0, the other 5 will be 1. You can put 1. If you choose any 5 to be 1, you can put it as, you can put the rest of it as 0. So this will become 94. This is 6 into 7 into 8 into 9 upon 4 factorial, which is 24. This is 3. This is 2. 14 nines are 126. So this can be done in 126 ways. Now, case 2. Case 2 is you can get one AI as 1, one AI as 2, and 7 AI as 0, right? So 1 plus 1 plus 1 plus 1 plus 1 is 5. Then 1 plus 2, 1 plus 4 is 1 plus 4 plus 0 plus 0, like this is 5. Is there any other way you can get 5? There is no other way, right? So here this can be done as, out of these 9 elements, you can choose any one to be 1, any one to be 2. So you can do it in 91 into 91 ways, which is equals to 81 ways. So the total answer is the sum of these values, which is 207. So the answer to this question is 291 into 91 ways. Oh, okay. 91 into 8C1 ways. Because why 8C1? Because out of all these 9 AIs, you would have selected one already, right? In this 9C1. So the remaining will be 8C1. So this will become 72 instead of 81. And the answer to this question will be 198. Okay. So the answer is option A. Okay. So I hope guys the session was helpful to you. Tomorrow also we will discuss some questions on matrices and determinants for JEE mains. Sorry, for JEE advanced 2023 practice. And I hope you guys perform well. All the best. Thank you for watching and please come again.